Hi, I'm Mike. I've got 9 o'clock right now. 10 o'clock? What time zone am I in? 10 o'clock. I've got 9 o'clock. You all have 10 o'clock. Still people wandering in. That's cool. Are we good on volume? OK. Welcome to the first breakout session of the day, I guess. We're going to be talking about why is my Solr slow. This is going to be a case study, sort of a case study, using Apache HTrace. A little bit about myself first, just so everybody feels more comfortable. I'm a committer on Apache HTrace. It's an incubating project. It's open source. For my day job, I'm a software engineer at Cloudera. We're based out of the Bay Area. I'm personally based out of Houston, Texas. I work remote, but travel a bunch. That's part of the reason I get to be at cool places like this. And then in my free time, there's a couple middle school Lego robotics teams that I hang out with. One of them's a Girl Scout team. They're really, really smart. They're going to take my job someday, and I'm going to be obsolete, and it's going to be awesome. Yeah. So basically, we're going to cover a few things during this session. First, I'm going to talk about why do we even need this? Why am I here? Why am I presenting to you? What's kind of the goal of tracing and distributed tracing? I'll talk a little bit about what HTrace is, since I assume most of you are already familiar with Solr. Most of you at least have a basic level understanding of what this search engine that we all work with and we're all here for is. But you probably aren't familiar with HTrace and what this is. Then I'll go through a couple of quick examples of what this integration looks like, and then we're going to hop into finding how do we actually use this to find the slow server? What does this mean? Originally, that was going to be a demo. My Wi-Fi VPN flaked out. I apologize up front. But I do have backup slides, yay. So you get twice as many slides. Exciting for you. So the scenario, and I'm sure we've all been there, is right, like the user complains that queries are slow. I work with customers a lot, and this is the most infuriating question that we can get. I mean, it's also the most fun one sometimes, but like, oh, my query's slow, can you help? What does that mean? Why could it be slow? What is, is it your caches? Your caches are bad, or something that you're doing with faceting or sorting? Or is it like you have a bad disk somewhere? Or is it that your replication strategy is bad? Or is it like, you have this whole checklist of like millions of things that it could be, and you never know what it is because every customer is different and every application is different, and eventually you get like kind of this feel for it, but it's super messy, right? Like it's never an easy answer. So one of the things that we like to do sometimes is Solr has this feature, like you can throw debug equals timing onto the end of your query. There's a couple other options for debug, but timing is a pretty generally useful one, and it'll show you up here. How do I get my laser pointer? Yay, there we go. So you have your whole time, and it breaks it down. I actually cut out a lot of zeros from this because normally it gives you a lot more information. But we see that processing took 160 milliseconds, query took 120, faceting took 30, and we'll say that this is like a typical baseline query, baseline, whatever. But the interesting part is that, hey, we can actually get this kind of breakdown. So what are we doing that's different? What is Apache HTrace? It's a distributed tracing library, and the primitive type is the span. So instead of, back here, we have like this whole aggregate thing, we're going to go to a a different kind of measurement where it's a span. And a span is identified, it has a unique ID. It's 128-bit mumbo jumbo. And then we can throw a source and a description on it. Because it's a distributed system, it's really important to know where your traces are coming from. So if I have 100 servers and I have, oh, a query took 10 seconds, like, that doesn't tell me anything. But having a source and having a description makes them identifiable. And then start and stop time, it's a timeline. We'll see more of that in a little bit. And we can throw additional metadata onto the spans. You can throw a key value annotation, you can throw a timeline annotation that at this time something happened. This is all pretty abstract right now. We'll get into more examples later. And the additional metadata is really just a convenience thing. You can ignore it, it's completely optional. It's something that you could extract from the description by just shoving more and more information into the description, but sometimes that's not a scalable approach. HTrace owes its origins to Dapper. It's a paper published by Google about how they do distributed tracing, and as is the motto in a lot of modern tech, if it's good enough for Google, let's try to re-implement it. Twitter did it, they called it Zipkin. Nike, very recently, it was just this summer, published something called Wingtips. That's their version of a tracing framework. All of these frameworks, they're all largely compatible. They all work with this primitive type of the span, and it's pretty straightforward to translate. HTrace and Zipkin have this translation layer. Wingtips doesn't have it yet, but if somebody wants to do that, it shouldn't, I presume it shouldn't take that long. I haven't personally looked into it, so I don't want to make claims there. And then Dapper, of course, the original granddaddy of all of these tracing things. So what does this look like? All right, you have your distributed application. You have it on, in this example, we have 4 nodes or 4 instances, 4 containers, 4 whatevers, right? And each one of these you instrument with some kind of trace generation. This is code change. You do have to add segments that you're tracing into the code. So it's not something that you can externally add like a profiler or a Java agent, anything like that. But once these generators are in there, then they'll all start sending traces to some sort of centralized collector, in theory. What does this look like for Solr? Well, we can say we have 3 or 4 Solrs. One of these could be a different application, like it could be your client, your indexing tool that's also generating these traces. And HTrace comes with a daemon called HTraceD, very creatively named, that will collect these. If you want to swap this out for Zipkin, the Zipkin collector, because it's much prettier, as lots of Twitter technology is, it looks very, very pretty. Then at this translation layer, you say, okay, you're not sending it to an HTraceD, you're sending it to a Zipkin receiver, and that all gets taken care of on the back end for you. Okay, so we know what this looks like. And I said there's code change, so some of you probably maybe got scared a little bit. You're like, oh no, I don't want to write code. I just want to see the results. Luckily, I've written most of this code. But if you want to do this in your own application because you want to integrate this, right? You want the tracing from your code to go along with the tracing from Solr and the tracing from everything, so you can have this nice complete picture. The idea is you can trace anything that's a unit of work. So a method call or several lines or several things. A thread execution like callables and runnables are great examples of this in Java land. Or over RPC. So you send a request, the whole request is one trace, right? And traces can have subtraces. We'll see more of that in a couple slides. But the general idea here is that you have some method, and you create a scope around it. Once you configure your tracer object with, basically you need to give it where it's going to send its spans to. So you create a new scope. This is your description right here. It's a string. The source is already going to be set up for you. And then you do your normal operations. At the end of this block, when the span closes or the scope closes, it'll complete the span and it'll send it off on its merry way to the receiver. So what does this look like? It's kind of hard to see the text here. I tried to just give you a high-level picture. So we have, this was a q equals star colon star, just get everything query on Solr. And the data that I modeled here was on the original debug equals timing model. So we have all of the same information, except a little bit more. And here at the top, we see that this top one this is your whole operation. And then here along the left side, we see there's a couple of different IPs. There's a .61, there's a .49, and a dot. I can't read that, but it's different. You'll have to take my word for it. It's a bad angle here. So we see the search handler, and then some other search handlers from other IPs that this query gets distributed to. And this gives us a pretty good idea of a typical query lifecycle and a typical what's going on. Here I've expanded one of the process phases, and we see that, okay, all the time took was in the query. All of these other components, terms, expand, facet, blah, 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 they all did nothing because I didn't ask for that in this query. So great, that's the results that we expect. I've mentioned debug equals timing a couple times. And so if that's what we're modeling our data on, if that's what we're looking at, then what are the benefits? Why did we go through all of this work? First of all, we can see back here separate timelines for each server. So we have search handler up top, down here, 3 more, expand it, and then 2 more down here. So that's pretty useful if you need the granular information. We also have the ability to mark annotations. I haven't done that on there, but if you have annotations available, they just show up with the spans. It's a little tick mark on the timeline, and it'll show up like a comment in Excel or additional information. It's cool that the data can be stored for later analysis because you have this daemon collecting everything. That's maybe interesting. You can already do that with debug equals timing if you're aware that that's something you need to do. If you want to do trend analysis and you start saving this data, but that's on you then, and you have to manage how you're saving it. That's kind of hard. One of my favorite parts of this is that we can trace things that are not queries. Debug equals timing only works on queries. If you're doing indexing, if you're doing updating, you'll still get queue time on your response, just the whole amount of time that your request took, but you can't get any granular information. And queries are only half the story. At least in my systems, queries are only half the story because we also need to get the data into them. And then there's the possibility that other systems that are also tracing, we can get this integrated analysis. Spans have that parent-child relationship that we just saw, so we're not limited to just tracing in Solr. So here's something a little bit more complex. It's the same query, but I added a facet. And we can see that the way that this changes is, we have a query block here, and we have a facet block here. I don't know if the laser pointer's showing up dark enough for people to see. Oh, and it died. Oh, whole thing died. Okay. Probably battery. So I'll come back here. So we can see that there's the query line and the facet line. just a little bit more complex, but otherwise it's all the same thing. I mentioned that we could trace other commands. So here we have a bunch of updates. And then at the end, I've expanded these these bottom three, and we can see that it's an update that has a handle commit that goes to an update handler on a different node that then actually does the commit there. So we have 3 commits, we have 3 different servers. This all is the expected behavior. The commits take much longer than the individual updates. That's also reasonably expected behavior. And we can look at this and say, okay, yeah, the system's working how we expect. One more, collection creation. The local creation command executed much faster than the 2 distributed shard creations. This was creating a shard or a collection with 3 shards. All of that was just to show you the kinds of things that we can trace and the kinds of things that we can reason about. There's a little bit of a snag with the configuration. Like we have a new component, we need to figure out how to configure it. A simple approach, we can add a new section in Solr.xml, configure the span receiver, whether that's going to be going to HTrace or Zipkin or whatever else, tell it where the trace server that's accepting things is. And then there's this thing that we have to consider that HTrace does about samplers. There's a couple of different samplers. One of them is called the always sampler, and one of them is called the never sampler. They do just like what they sound like. And really, a sampler is a pluggable class that'll decide whether you want to trace this particular request or not. We don't want to trace every single request. My Solr servers are busy. This introduces overhead. I'm not going to stand up here and tell you that this is free. We'll talk about the performance and overhead on the next slide a little bit. But samplers, there's one called the probability sampler. And you can say, OK, 1 out of every 1,000 queries, trace that. That's a pretty reasonable default, I've found. But we'll have the option to force a trace. If we include in our query parameters trace ID equals blah, just throw it some kind of ID, then that's going to tell Solr, hey, this is already part of a trace. We need to trace and generate all of the sub and child traces because somebody out there is expecting results. Also, you might want to consider buffering options because these traces sit on the Solr server until they're ready to get collected. It's not a ton, but it is a little bit. So each trace, I hooked up a profiler to it, adds about 25 nanoseconds of overhead. And if you're out there and you're thinking, well, 25 nanoseconds, that's like nothing. Why do I even care? And if we do system.get milliseconds, I'm not even going to notice that. Well, one search, because we saw all those components, that's 20 traces. And then if you distribute that, that's 20 traces per shard. And then if you have thousands of queries per second, you can see where I'm going with this. This adds up very quickly. On top of that, traces are buffered in memory. The default is an 8 megabyte buffer. That's not very large, but the traces aren't very large either. This will sit in your heap. We want to buffer because sending all of these small items over the network isn't efficient, isn't performant. But it is, if they're sitting in the memory, it is something that you might need to consider if you're already having memory issues on your large-scale Solrs. If you're not anywhere near your memory, then yeah, sure, buffer away. And if you have low load, then you can crank up the probability sampler much higher. But we're not trying to get performance on every single thing. we're trying to get trends, and we're trying to identify individual problems. If you start seeing network issues or kind of buffering problems, you might want to consider multiple trace receivers. I haven't done this with Solr, but I've talked to other people that have done this with other systems, and they say it worked reasonably well. That's kind of a future consideration. Other future considerations are, oh, I'm missing a bullet, okay. You know, we'd want to get tracing into Solr J, into the clients, because currently it's only in Solr Core. It's only on the handlers, it's only on the operations that Solr is doing. There's also a lot of overlap with the MDC logging that we might be able to leverage. I don't know exactly what that looks like, but intuitively it feels like something that should be doable and should have benefits, right? We're looking at a lot of the same things. And then also, async requests are a little bit harder to reason about because you'll have a trace here, and then the asynchronous part is going to be later. It's not going to be an overlapping timeline. So what does that look like? So here's where instead of the demo, we have backup slides. So say we executed this query and we see somebody's complaining about it, and you know, oh my, this queue time is much longer than I expected it to be. Look at that, it's 5 seconds. My query should be taking less than 1 second. And yeah, like this is a problem. So what's worse is they say, sometimes my query executes fine, and sometimes it's really slow. Well, okay. That sounds like maybe a caching issue. I don't know, like sometimes you hit a cache, sometimes you don't. So let's say you've gone through all your typical cache diagnosing steps. That could be its own presentation, really. So I'm going to skip them here. And you say, no, it doesn't look like caches. It's got to be something else. But we don't really know what it is. Okay. So we know that it's a search. We know that it took 5.5 seconds. So this is from the HTrace collector UI. We can just do a simple search and say, okay, well, what searches have been traced that take longer than 5 seconds? Okay, great, we found this one. And then we start expanding it. And we see, okay, well, there's a distribute that looks pretty quick. There's a distribute that looks much longer, and then another couple that are also pretty quick. So let's focus on this long one. What's going on there? And then as we expand that, we can see, oh, okay, this is on a particular server. If we run multiple of these queries, we can start seeing that, you know, hey, this .166 server, something's going on there. Something's weird. And in this case, I changed the code so that it would sleep in the facet method. Very fabricated example. But in other cases that we've actually seen this, there was a bad disk. And sometimes it would be going to a good replica where the disk was fine and everything would return quickly. And other times it would be going to this slow disk that had a lot of contention on it, and just the queries would take longer. It would take longer to read them. Yeah, so here we can see the facet method took a long time. We can identify 166 as the slow server, happy ending to the diagnosing story. So thank you guys for listening to me. Thank you for making this a packed room. I'm happy to take questions. Do we have microphones for the questions? Or I'll repeat it, I guess, too.
Yeah, I was wondering, you talked about the probability probability sampler. Can that be changed on the fly, like what interval you're sampling at? Does that require a core restart?
Yeah, so right now, it's just read once, but there's no reason that it has to be that way. The question was, can we change the probability sampler? Can we change the frequency on the fly? So right now, no, but theoretically, yeah, that's a pretty reasonable thing to do, especially if you see that, oh, this is too frequent, this is overwhelming my servers, it's causing performance issues, or this is nighttime. And if you want to have more kind of complicated samplers based on time of day or something like that, then those are also not terribly difficult to implement. That question back here.
So you showed like the code that you'd have to add with the try block.
Sure. Yeah.
So are you saying that's already in Solr, or do you have to deploy certain components that wrap the existing ones to add that in?
So I have, that code is on my local version of Solr. There's a Jira, that was the bullet that I mentioned I'm missing, because I added follow Jira something, I don't remember the number off the top of my head. So at some point, I hope that will be in Solr for you already. Right now it's not, but that's if you wanted to add tracing to your client application, that's what it would look like.
Hi, I think you mentioned that about historical data. You can store historical data. So what are the options for that? Is that something which the tool provides, or you have to do it externally?
Can you repeat the last part of that?
So is this something which we have to do it externally, or something the tool provides?
Oh, sure. Yeah. So HTrace D will store data for you, because that's how it generates those graphs. If you want to store your debug equals timing data, that's something that's on you to do. And that was one of the things that I was mentioning as an advantage of having a system dedicated to this instead of more ad hoc queries. I think you and the red scarf had a...
First, about the samplers, can I sample based on the metadata? For example, if I want to sample only queries with wildcards, if I add custom metadata and then sample only the traces with this metadata, is it possible?
The samplers don't take a lot of stateful information. That's something that we would have to add at kind of an application level. So yes, it's possible. Anything's possible. It's all code.
Yeah.
That's a very flippant answer.
So it's static. It's
Yeah. It's
I need to wire it in myself.
yeah. You would have to wire that in yourself. As this matures in Solr, then there might evolve a sense of like, oh, these particular kinds of samplers are more useful specifically to Solr, right? Because HTrace is a general purpose tracing system. They don't have lots of things that could be specifically useful to Solr. But samplers based on metadata sounds like a good idea. Completely agree.
I have a question about these source code changes. Have you considered using bytecode instrumentation instead?
Yeah, that was one of using bytecode instrumentation would work, except we'd be missing a lot of the descriptions that we can throw in there. And I guess you could still do it with bytecode instrumentation. But if we already know, this unit of work, this is a search query, we can label that as a search query. And it's much easier to do that at the code level instead of at the bytecode level, especially with regard to the labels and any additional metadata that we want to put in.
So, two related questions. How is the communication between Solr and the collector? and I mean the client application and the collector, and is that collector something that could be changed with something else, or is that something custom protocol that's being used?
Sure, yeah. The particular collector here, the HTrace D collector, I believe it's Thrift RPC that it talks to. Changing out the collector, if you, so back here, so one of the configuration options is span receiver classes. So we can say, okay, I want, instead of the HTrace D receiver, I want to use the Zipkin receiver, or I want to use the log4j receiver. And that'll change where the spans get sent out to. And that'll change the RPC protocol as well. I think there was a, oh.
So you mentioned several different tracing products, HTrace being one,
Sure.
the Google one, the Facebook one, the Nike one. What's unique about HTrace, and why would we pick that over a different one? What are the sort of the pros and cons?
Sure, yeah. Well, you can't pick the Google one. That's as great as it is, that's kind of the end of that story. The Twitter one, Zipkin, has a really great front end for displaying the traces, better than the HTrace front end, I'll admit that. But the trace generation is a little bit more cumbersome. And then from what I've read on Nikes, on wingtips, they don't have any front end at all. It's all, or they have one, but it's not published. I think it's internal to Nike. Does that make sense? Okay, cool.
Just to follow up that question, what is the performance metrics of each one? Do we have any benchmark? How does HTrace perform compared to the Twitter and Facebook?
Yeah, so the question on how does HTrace perform compared to wingtips and Dapper and Zipkin, and I have no idea. I don't know of anybody that's done a comparison there. I think somebody has a microphone over there.
For distributed queries, how do you pass that parent span down to servers? Like you have three shards, and how you pass that?
Sure. Yeah, so here we can see in the advanced forcing a trace, if we add trace ID equals this ID to the query, then that forces a trace. We can reuse that when we're distributing between, shard 1 to shard 2 and 3 and 4. If we say, I'm already tracing with trace ID equals blah, then that gets passed along. So for things where the nodes communicate directly with each other, that's pretty easy. For things where they communicate through the overseer for kind of admin operations, because it has to go through the overseer, go through Zookeeper, go through another RPC, that's significantly more complicated, but the general idea is still keep hold of this trace ID throughout the RPC chain and add it as a attribute on the message. So where's the microphones? Oh, there's one over there.
I'm wondering if you have any limitations in the number of nodes that you can instrument at a time, and what is the retention rate you can hold for these spans? Is it like days and weeks or months to years?
Sure, yeah. There's not, this is kind of a non-committal answer, that as your number of nodes that you want to instrument goes up, then there's not really a hard limit because you can just keep lowering your probability sampler. So that's one technique to scaling. I don't know what the upper limit of, how many nodes can we do at a probability sampler of 1%. I think that's on the order of hundreds of nodes, but I haven't I haven't thrown a system at it for 24 hours to check that thing. As you get more nodes, you decrease the probability sampler to adjust your volume appropriately. For the retention, HTrace D stores it just on disk. That's a function of how much disk you want to give it. A typical span is, I think, tens of kilobytes, not even, or tens of bytes. Because it's a couple strings and a couple timestamps at its basest. So it doesn't take up very much room. I don't have a specific number to give you on that, though.
So two questions. Two questions. I'm assuming that you already have a Jira for flushing to disk, rather than holding it all in memory before then sending it RPC over to the other node for the collectors, just get it off the memory heap. But I would assume. Secondly, just theoretically, why wouldn't I just be able to re-ingest this data instead of to HTrace D or whatever, or any of those other things? Why couldn't I just re-ingest it back into Solr and do all my RCA and diagnostics on that?
Yeah, so the question of why can't we use Solr, you could. It probably would work great. I haven't tried that yet. I wanted to use existing pieces. As far as flushing to disk, I don't think that anybody's really thought about that yet. But yeah, it's totally a reasonable thing to do. And I'm told I'm out of time. So thank you guys. Thanks for coming. Great discussion at the end.